Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our homework. Lesson 4.1.3, problems 25 through 29. Two of the connections in your representations of patterns webs are pattern to table and pattern to rule. So practice these connections as you answer the questions below. On graph paper, draw figures 0 and 4 for this pattern at the right. Okay, so what does this pattern look like? It starts off with, oh no. Keep doing this. Starts off with 5, and then 1, 2, 3, 4, 5, 6. Then it adds 2, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. So it adds 2 every single time. So that implies that we're going to have a pattern of growth, a constant growth rate of 2 tiles per figure. So 2 tiles per figure. Now let's work our way backwards and taking off those 2 tiles, which means this would be like if these are always added, the 2 are always added on the top row and the bottom row, and figure 3 has had 3 sets of 2 added. This has had 2 sets of 2 added. This had 1 set of 2 added, so figure 0 must be just those starting 3, and that right there is where we start. So figure 0 would be those original 3, and then every figure thereafter adds 2. So the 4th figure has added a total of 8 onto the original 3. 1, 2, 3, 4, 5, 6, 7, 8. And so this ends up being the rule that fits for this particular situation. Y equals 2x plus 3. So now I can tell you how many tiles will be in the 50th figure and the 24th figure, or I could tell you which figure has 83 tiles in it, just by using this rule and using our algebraic reasoning. I use the formula for the area of a circle to solve for the radius of the circle that has an area of 78.5 square centimeters. All right, well, we saw this in yesterday's homework where we started off with a circle with a diameter of 10, so its radius was 5, and then after going through the process, we found it had an area of 78.5. So now we're going to work that process in reverse. So we know that the formula is the area of a circle is equal to pi r squared. If we know what the area is, we're going to substitute that for a, and we're going to replace pi with 3.14 or the pi button in your on your calculator. And so the first thing you'll do is divide each side by pi. And so what is 78.5 divided by pi? Well, if I use the rounded off version of pi, 3.14, you get exactly 25. If you were to have had this as a rounded off area and you divided it by the actual value of pi, then you would see, okay, 24, well, we might as well just round it up to 25, right? It's very, very close to 25, so we would round it to 25. And now comes an operation that we have not really done yet in algebra, and that is if r squared is 25 and r squared is r times r, what number do you multiply times itself to give you 25 for an answer? And that would be 5 times 5. So that means the radius must be equal to 5 centimeters. Now we've got an operation that we use, which is called the square root. And we'll learn more about this later in the year. But when you find the square root of r squared, you're answering that question, what number do you multiply times itself to give you r squared for an answer? And that would be r, since r times r is r squared. And remember, algebraic reasoning, whatever you do to one side of the equation, you have to do the exact same thing to the other side. So the square root of 25 is whatever number you multiply times itself to give you 25 for an answer. And literally, that could either be -5 or +5. Since -5 times -5 is equal to 25, and so is 5 times 5. Now, which one of those is the correct answer? Well, we are never going to measure something and call it a negative distance. So we're just going to throw out the negative square root and only work with a positive square root. So anytime we're doing any work in geometry where we're measuring the length of something and we have to find a square root, we will always only go with the positive square root, which I think is called the primary square root. There's a word for it, it's escaping me, but the positive square root is a fine way to say it. Okay, so that would be the answer to the question. This particular circle with an area of 78.5 square centimeters has a radius of 5 centimeters. For each of the equations below, solve for x. All right, so if we're going to solve for x, the first thing that we would have to do is combine like terms, right? And this x and that negative x are going to cancel each other out, so we end up with negative 2 plus 2x equals 2. And then when we want to get these two x's by themselves, we would have to add 2 to each side to zero these guys out. That leaves you with only the 2x on the left, but we now have 4 on the right. So what do you multiply times 2 to give you 4 for an answer? It has to be 2, right? And we can prove that by dividing each side by 2. 4 divided by 2 is 2. 2 divided by 2 gives you 1x. So let's check that to make sure that it works. Negative 2 plus 4, right? 2 times 2 is 4, must be equal to the opposite of 2 plus 2. These two are going to cancel each other out because they're opposites, plus 2 again. So is negative 2 plus 4 equal to 2? Yes, it is. That proves our answer is correct. Here we've got what? Nothing can be combined. So let's begin the process of adding 3 x's to each side. And I want to collect them on the right side so I have a positive 4 x's instead of having them on the left where they would be a negative 4 x's. So these guys cancel out. They form a 0, leaving you with just the 2 is equal to now x plus 3x is 4x plus 2. So now since we're collecting our 4 x's on this side, let's take 2 away from the right side, which means we also have to take away 2 from the left side. And we only had 2 on the left side, so that means we're left with nothing. So we want to put a 0 there. We don't want to just leave it blank. When those guys cancel out, that leaves you with 0. Here I don't have to write the 0 because I've got the 4x. And 4x plus 0 is just going to be 4x anyway. So let's just leave it like that. So now, what do you multiply times 4 to give you 0 for an answer? Well, the answer is 0. Because when you divide this by 4, you get 1x. And if you divide 0 by 4, you get 0 for an answer. But in this case, it's probably just easier to think about 0 times 4 is 0, so x has to be equal to 0. So does that work here? Is 2 minus 0 equal to 0 plus 2? Yes, it is. So we know we've got the answer correct. Another way, or another one of the connections in your representations of patterns web is a graph table. In chapters 1 through 3, you develop tools to find a table from a graph. So consider this connection as you complete the table below. And I'm going to take one step further, and I'm going to write the rule for this situation because we know, well, I don't know, maybe you guys haven't been taught how to do this yet. I mean, we've generated rules from here. Yeah, let's do it anyway. Okay, so each one of these points, this point right there is at where x is 2 and y is 0, so that would be that point there. This is where y is 0 and x is negative 1, so that would be, no, x is 0 there, isn't it? And y is negative 1. So that would be this point right there. And this right here is where x is equal to negative 2 and y is equal to negative 2. And so we could plot the halfway points as well, since it appears as if to go 2 units up, this goes up only 1, which means for every 1, that goes up a half. And so that's the completed table. So what is our growth rate here? For every one of these that moves up, this increases by 0.5. And what's our y-intercept at negative 1? So our rule is going to be 0.5x plus 1. Or if we want to switch to fraction, 1/2 of x plus 1. Let's see if that works right here. What's half of 4? 2. And 2 plus 1? Wait a minute. Wait a minute. It's not plus 1. What is it supposed to be? It's supposed to be minus 1. I'm sure glad I checked that because that would have said my answer should have been at 3 instead of at 1. So that's why we check things, because it's so easy to make a mistake. It's supposed to be 1/2 x minus 1. So let's check that again. What's half of 4? 2. And 2 minus 1 is 1. So this point right there is at 4, 1. And that agrees with our graph. And that would fit in with our pattern here as well if we were to extend that table. So either way to write those two rules, either with decimal or with fraction. And our last problem, Joe drove 100 miles from San Francisco to Gilroy and used 4 gallons of gas. how much gas would he expect to use on a 3,000-mile trip to New York City? So finding the unit rate can come in very handy here. So if it's 100 miles for 4 gallons, how many miles would it be for 1 gallon? So to find the unit rate, you just do the division, and 100 divided by 4 is 25. So the unit rate is 25 miles per gallon. So if we now want to put that into a rule, the number of miles you can go at 25 miles per gallon, if I plug in 3,000 miles here and divide it by 25, that will tell me how many gallons it's going to cost me. So we can do it that way, or we could set it up as proportional reasoning, where we could cross multiply and then divide, and we're still, whether we say 3,000 is equal to 25x because we plugged in the 3,000 where the y was, or if we did the cross multiplying, we get the exact same equation. It works out exactly the same. So 3,000 divided by 25 ends up being 120. Let me prove it to you. 3,000 divided by 25 gives you 120. And now I'm just curious, what is gas costing these days? About $3 a gallon? So that's going to end up being 120, stop it, times about $3 a gallon. That's going to cost you $360. That doesn't seem right. Is it $360 worth of gas? No, it's 120 gallons. Yeah, maybe it is. Maybe it's just $360 to drive all the way back across the country. That seems low. But yeah, no, that's right. Okay, thought it was going to be more expensive than that, but turns out that's all it is. All right, so I think that ends our homework for today. How much time did it take? Almost 12 minutes. All right, let's move on. Take care. Bye. Bye.
Hey, feeling good.